Hello. Let me go over some tips for homework number two. Homework number two, the material you're going to use is for probability and probability distribution. So let me go over and see what I can explain to make this homework easier and clear what you need to do. So the first problem I ask you to do is we have a different license plate, four letter with two-digit number. How many ways you can do have a plate number? Remember, if you look at your probability handout which I gave you, if you look at multiplication rule, that is required multiplication rule. So basically what happened, how many license, the example you have, we look at three numbers and for three letters and three numbers. So the event one, the possible letter is 26 times 26 times 26 because we have three letters. And then 0 to 9 is 10 digit. We have three numbers, 10 times 10. So you get 17,576,000 ways. So you use the same sort of rule here. Now you have two-digit number and four letter. So that's the difference you can calculate. Now, question B basically is two letter, so and four digit. So again, is multiplication rule you're going to use to calculate that. Now, the second problem, what I'm asking is we have breastfeeding and breast cancer information. And here I'm asking some question regarding the probability. The first question is, suppose we pick a woman in random from this sample. What is the probability of this woman will breastfeed? So again, this is you have to define, remember the probability is the number of things happen, the number of events happen overall, the total sample you have. So here you have to define your event. The defining event is if woman breastfeed. So how many breastfeed you have, you're going to find and divide it by the total of sample size. So that's for part A. And if you look at the example I give you in handout, this example, we have the boys and the gender and age group. I ask you what is the probability will be boy. Here, basically, I'm asking what is the probability BB and breastfeed. So what do you call this probability? Again, if you look at the same example, you have the boy, so 104 total divided by 210, you got that probability. That's called marginal probability because you're looking at the marginal for each category you have. So what is the probability woman did not breastfeed and had breast cancer? So you have to look at the intersection. So it's basically the cell probability you're looking. Look at the example again here. What is the probability a student will be boy and between 5 and 6? So you find 5 and 6 and boy, there are 20 of them divided by the total, you get that probability. 20 divided by 210, you get 0.095. And what do we call this probability? This probability is joint probability. Now, what is the probability woman get no breast cancer given no breastfeeding? This is the sort of you given a condition which is no breastfeeding, the same as here. We ask what is the probability that a boy or is between 7 years, given the student girl, what is the probability that she is between 11 and 12 years old? So here when it's given, that means it limit you to that that marginal. So given no breastfeed, so you look at the no breastfeed, which is 1100, and then find that is your total sample. Now, what is the probability of breast cancer? You find the number of breast cancer happen in that row. So what we call that, and how many marginal probability do we have? The number of probability marginal is the number of row and column you have, excluding the total. So you wouldn't count these total. So here we have 1, 2, 3, 4, and we have 2. So it's 6 of those the total of marginal probability we have. So that is that is you wanted to count the number again for each of row excluding the total, so you wouldn't count these total. So it's just what is how many row, how many column you have, you added up to get that. So now question 3, basically that question again is about a screening test information. So we have positive test and negative test, and the question I ask to calculate basically what is the sensitivity and specificity and positive predicted value, and also what is the false positive. So if you look at your handout, you would be able to see a similar example you have here. So if you assign A, B, C, D, which is true positive, and here is your true negative, and this is false positive, and then false negative, you can easily calculate the sensitivity. For this example, is your yes and yes at your numerator divided by the total for your column. So here 900 over 1000, you get 0.9. And then a specificity is your 800, the true negative, over the true in no section, which is 810. And false positive is 1 minus specificity, and false negative is 1 minus sensitivity. You can easily calculate that. And then positive predicted value is your basically row column. So you have here number of positive over the total of positive in test, and negative is 800 over 900 would be negative predicted value. So this question basically asks you to calculate that based on the example you have. You should be able to easily calculate that. Now, question 4, I ask you, let's say percentage of American adult smoker is 0.20, which is 0.2. Suppose we take a sample of 10, find the probability find the probability that number of smoker in the sample would be. So here we are talking about the distribution. So here you have, if you have N and P, that is your binomial distribution. So and here you can choose 2 ways to calculate. If you remember the example we have, either you can calculate from table the probability, or you can calculate by function, binomial function. So you can use the binomial function. Remember, binomial function, if you look at your handout, it's f of x n choose x, p of x 1 minus px n minus x. Remember, p is your probability, like your problem is 0.2, and then your n is 10. So, and if you look at the example here, you basically, when we want to find the probability for something, we said we replace x with that and just calculate this function. And like for example, here our p was 0.3 and 10, and we wanted probability exactly to, we basically replace n by 10, p 0.3 x with 3, and just calculate this. So you have two choices, and the other option you can have is using the tables. So looking at the binomial table, so here you have, remember there are different tables you can use. One of these tables, let me show you a couple of these tables. So one of these tables is show you the n, and these are the p, and these are x or r, call it. For example, probability, if you look at 0.3, this is your 0.3 here, and then our n was for this, let's say n of 10, so that was our n of 10. For exactly 2, this is cumulative probability. So if you look in that, so you have to take, that means this is the probability 0 plus 1 plus 2. So you have to subtract 0.121 from the 0.233 to get that probability. Just be careful. When you're looking at the table, if it's exact, if I say probability less than equal 2, then you can use this number. If it's exact, you have to subtract from the above value for that. So basically what you need to find, what is your p, what is your n, and what is x you wanted to calculate from this table. So there is two ways you can calculate this. So what is the mean number of a smoking sample size of 10? What is the variance? That is very simple calculation based on, again, the probability. We know the mean is n times p, and the variance is n times p times 1 minus p. So you have that information, you can easily calculate that. So problem 5 is, here we said, let's say we have nursing student pass and class is 0.96. What is the mean number of nursing student pass, sample size of 50? So basically, again, you have n times p, you can calculate that. Let's say the mean number of fall in hospital for 1 month is 4. Find the probability that is next month there will be this number of fall. Remember, these kind of things, when the number of patient comes to clinic, all those fall in Poisson distribution. So again, you're going to use the Poisson distribution from your handout. If you look at the example, this is the function for Poisson. This is again example we have. Basically, for exact, you replace your x. So you have one parameter lambda, which is your example. It says the average 4. You replace 4 there, and then x replace, and then calculate that. And also, again, you can calculate from your table, Poisson table, which is, again, you have your lambda, and this is your x. For example, if I wanted to calculate for if the average of something, if the average of patient comes every hour in a clinic is 2, and I want to see exactly how many patients arrive in the first hours. So this is your lambda 2 for if is no patient comes at all, would be 0.1353. If I want to calculate uh, again for if the less than 1, then this is 0.2707. So again, you can use either table and or calculate it from the function. So here again, exactly 5, no fall, which means 0. You can calculate that. Now we get to continuous distribution. Question 7. What I'm asking is, given the standard normal distribution, find the following area. So you have to use the z from the z, find that value. Basically, if you look at the handout, uh, this is we talk about the z. If you wanted to find something, basically the z table, these are the value you have, and the top is the second digit, and the body is the area. When we talk about if z less than some value, means to the left of, this is your z distribution, to the left of that value. So for example, if I'm asking you to find something, if what is the z value, negative 3.3 5, that means this is your center, which is 0, negative 0.3 somewhere here, and you would look at negative 0.33 and 5, that would be your area, 0.0004. So that's, I'm asking for this. When you have two value, probability z, for example, if you have probability something negative or positive, doesn't matter, negative 2.1, and z here would be z 2.1 positive. That means you first write this as two equations. First, probability less than 2.1. Then you subtract the second term from the first area. Probability z less than negative 2.1. So you go from your table, find these two probability and subtract from so for negative 2.10, remember this is 0 column, so negative 2.0 is 0.0179, remember that, and then you find positive 2.1 which is 0.9821. Basically, then you would write as 0.9821 minus 0.0179. That gives you the area. See, this is the area we are looking. So let's say negative 2.1 is here, positive is here. We wanted this area. When you find the 2.1, that means this area, and then you have to subtract the negative 2.1 because you have done that. So basically, that is the way you're going to calculate all of these probability. Now, problem 8, I give you the area and ask you what is the z value. So basically, again, if I tell you what is the value for the area 0.1492, this is the area. So the value would be negative 1.0, and you find second digit 0.4. So it's negative 1.04 because that is the second decimal point. Or what is the area for 0.0008? What is the z value? Is negative 3.17 because 7 is there. So again, sometimes you have the area, you wanted to find the value. Now here is a little bit tricky. So you have to you have the area, you have that you have the one value z. So the question is to find the Z1. Again, you would write these as this equation. So basically, you would write your 1.96 here, and then here Z1, and then here you have, the value is 0.95. So then what you do is simple math. What you need to do, you can find this value, and then you subtract this value from 0.95. Now you have the area for that. Then you find the value for Z. So it's a couple of steps you have to do, but it's just if you follow the step, you would be able to find the Z1. Question 9, we get to the distribution. When we know, it's asking, we know the population, if the population normally distributed with the mean of 100 and the standard deviation 10, what is the probability fifth grade select at random here? So basically here what you have is your sigma and the mu. I'm asking you what is, if the weight of the fifth grade be less than 90. So you have sigma and you have your mu. So you're using the distribution from continuous distribution, which is you standardize to Z for your distribution, which is x minus mu over sigma. So basically you're using to get the Z and then find the Z value there. Again, between 80 and 130, first you want to convert these two values. So basically what you have here, so you have probability AD and X basically to 130. So you wanted to write this as Z value, which you convert AD minus 100 over 10. Then that would become your X minus mu over sigma, which is this is equal to Z, and then you do the same thing here, which is 130 minus 100 divided by 10. This gonna convert, this would be your Z, because that is Z formula, and this becomes the Z value. Then you find it like this. The first problem, you find the area. Now problem 10 is similar to problem 9. The only thing here, we have n also. This is your mean, and these are actually the x bar is not the x, is the mean for your sample. So the formula, you have additional, you still have to convert it to Z. What you need to do is using the formula, which is x bar minus mu divided by sigma over a square root of n. So because you have n, your denominator basically is the denominator has a square root of n addition, and then instead of x, now you have x bar. So you're using this formula to convert those value, and then easily when you have the Z, you can calculate the area. Remember, when you have something greater than, you have to do 1 minus x bar less than, so you can convert it that. So I hope these tips help you to understand what you need to do for this assignment.